Hello children, today we will revise chapter 3, a pair of linear equations in two variables. Here I have written pair of linear equations in two variables. One equation is a1x plus b1y equals to c1. Other equation is a2x plus b2y equals to c2. Where a1 and a2 are the coefficients of x, b1 and b2 are the coefficients of y, and c1 and c2 are the constant terms. So if without plotting the graph, we come to know which type of lines will be there, how many solutions will be there, whether it is consistent or inconsistent. Especially this type of questions can be asked for 1 marks. Okay, let's see how we can answer it. So first step here is we have to find out the ratios. A1 upon A2 you just find out, B1 upon B2 you have to find out the ratio, and C1 upon C2 you have to find out the ratio in simplest form. And then you have to observe that if you're given, you're just observing that a1 upon a2 is not equals to b1 upon b2, means the ratios of the coefficients of x is not equal to the ratio of the coefficients of y, then we will get intersecting lines. Yes, we will get intersecting line. For this condition, a1 upon a2 is not equals to b1 upon b2. Intersecting lines means the lines are intersecting at only one point, and since they are intersecting at only one point, therefore we will get only one solution, that is known as unique solution. And since we are getting solution, at least one we are getting, then it is known as consistent. So this pair of linear equations in two variables is consistent. So hope first case is understood. Now next, if you observe that a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, means all three ratios are equal, then we will get coincident lines, means both the lines will overlap on each other. And since each and every point are intersecting because they are coincident lines, so we will get infinite solution. There are infinite intersecting points of both the lines. And since we are getting infinite solution, it means I am getting solution. Therefore, it is consistent. Consistent means we are getting solutions. Therefore, it is consistent. Now, the third case is if a1 upon a2 equals to b1 upon b2 is not equals to c1 upon c2. Okay. So, whenever you observe that in third case, if a1 upon a2 is equals to b1 upon b2, means the ratio of the coefficients of x is equal to the ratio of the coefficients of y, but it is not equal to the ratio of the constant terms, that is c1 upon c2. So a1 upon a2 equals to b1 upon b2 is not equals to c1 upon c2. In this case, we will get parallel lines. Means these two lines never intersect at any point. These are parallel lines. Since they are not intersecting, therefore we are not getting any solution. So no solutions. There will be no solutions for this case when a1 upon a2 equals to b1 upon b2 not equals to c1 upon c2. Since we are not getting solution, therefore it is inconsistent. So it is inconsistent. So these three cases we have to learn. We have to remember. Okay. So here let us see in this question how that relationship will be beneficial for us. So here, as I told you, what is a1 and a2? They are the coefficients of x. So a1 is k, a2 is 12. b1 and b2 are the coefficients of y. So b1 is 3 and b2 is k. And the constant terms are minus k inside the bracket k minus 3 minus k minus 3. This complete term is c1, and this one is c2. So here, since what is the question for what value of k will be the following pair of linear equations have infinite solutions. So for infinite solution, I know the condition. What is that condition for infinite solution? For infinite solution, we know the condition is a1 upon a2 equals to b1 upon b2 equals to c1 upon c2. Now put up the values. a1 is k, a2 is 12, b1 is 3, b2 is k. Only you have to take the coefficients, don't take the variables. Here the constant term is minus k, and if there is minus sign outside the bracket, sign will change. So minus k, minus into minus plus 3 whole upon, this is minus k as it is. Or you can leave that minus so that both the minus will be cancelled out. Okay, so now you're having this much. Now what you have to do, cross multiply. You have to cross multiply the first two fractions and the next two fractions. So one is k by 12, 3 by k. The other one is 3 by k, k minus 3 upon k. Minus minus cancel out. So now solve it. It is k into k square. 12 3s are 36. When k square will shift on right hand side, it will become square root, and square root of 36 means plus minus 6. Whenever you open the square root, there will be sign plus and minus both. Okay, now let us solve this. 3k and then k into k square minus 3k. What we are doing here? Cross multiply. Okay, next is k square. Then this 3k will shift there. It is minus 3k equals to 0. I am shifting this left hand side 3k to right hand side. So k square minus 3k as it is, and this plus 3k will become minus 3k. So finally I got minus 3k. Same signs, add the numbers. 3 plus 3 is 6, and the common sign is minus. Minus 6k equals to 0. You can take k common out. K minus 6 is left. Okay, then either k is 0 or k minus 6 is 0. So if k minus 6 is 0, means k equals to 6. So you got here, since it was quadratic, degree is 2, you will get the values for k, 2 values. K is 0, k is 6. Here you got 2 values plus minus 6. So the common value from both the cases I am getting k equals to 6. So finally answer will be k equals to 6. Because k equal to 6 we got from both the cases the common value. Here 0 and 6, here plus minus 6. So plus 6 and plus 6 is the common one from both the cases. That's why the final answer of k will be 6. So this type of questions can be asked for 2 marks. So you have to prepare well and you have to learn the relationships of the ratios. Thank you.